Good afternoon, everyone. My name is Ben Weisenberger. I'm an application engineer with Allied PLM Solutions. I want to welcome you to the Allied PLM Lunch Bytes series. These sessions are designed to briefly explore capabilities within Solid Edge that you may not be aware of. Today's session is on what's new in ST5 Part 1. If you have any questions during today's session, please write them down and send us an email. We want these sessions to be informative to you, so please send us any topics that you want us to cover for future Lunch Bytes. Some of the topics we'll be covering today, we'll go over some live rule changes, talk about bounded surfaces and some new options. We'll look quickly at the round edit behavior and also some thread behaviors. Show you the sheet metal dimension to bends. Also, we'll talk a lot about multi-bodies and then a little bit about dimensions as well. So we'll get right into live rules. New options have been added to live rules to make it easier to understand and control how the settings affect a synchronous edit. So every time you do a synchronous move, this box will appear over here with these new options. And the solution manager, which is the magnifying glass down here, it gives the user the ability to graphically interact with the model to control all relationships relevant to the current solves. It can be activated manually during a synchronous edit by selecting the Live Rules Preview button, which is the magnifying glass. It can also be activated with Control-E during a synchronous edit. If the Solution Manager is activated during a synchronous edit, the user can return back to the dynamic edit state by either clicking the green check mark or double-clicking the left mouse button, also pressing the Enter key. While you're in the Solution Manager mode, the model comes up with a lot of new colors here, and this is what each of the colors mean. Green stands for the select set, that's the face you're moving. If it's light blue, that face is found and solved, so it'll also make the move with you. If it's a black face, then it's grounded. Red face is an isolated face, which is removed from the solve, and I'll show you that in just a minute. And dark blue is solved, but with some severed relationships. I'll show you that as well. Purple is a driven face, such as a web feature or patterns, and orange has failed to move. While you're in the Solution Manager mode, you can right-click on a face to expose all the relations that are found with that face. If you hover your mouse over those relationships, it'll highlight what exactly those relationships are. So you can see here with the first example, it's tangent connected. If you hover over that, it'll show you these two faces are connected tangentially. Same with concentric over here, the round and the circle are concentric, so you can hover over that and it'll show you what those are. Also, you can hover over, like this is a coplanar relationship. If you hover over the similar button over here to the left, it'll show you all the similar faces that are coplanar with it, and I'll show you this example in a second as well. While you're in the Solution Manager mode, you can also click on a grounded or locked feature, and it'll toggle that constraint. That face will become dark blue, which means it has a severed relationship, and then after you make the move, it'll go back to black and it becomes grounded again. If you're in the Solution Manager mode and you click on a face, it'll either isolate it or add it to the select set. You also have the ability to relax live rules, and you can also relax PMI dimensions. If you make a move with a locked dimension and you relax that dimension, after the completion, the dimension will become locked once again. And you can also relax persisted relationships. And if you break one of the persisted relationships, let's say you rotate a face to break a parallel, such as this down here, these two faces are parallel, and you rotated the face and break that parallel relationship, it'll tell you then in Pathfinder that that relationship has been broken. So we're going to go to Solid Edge real quick, and I'll show you some of these with the part here. So if we go ahead and grab this top face, you can see down here are some of our new buttons. Here's the Solution Manager. So if we grab the steering wheel and make an edit here, we can hit Control-E on the keyboard, and that'll bring up Solution Manager. You can hit the green arrow to exit out or double-click, and that'll take you back to your move. Also, if you click the Auto Solution Manager down here, what that does is after you place or make your move, so let's move this up, we'll place it, it comes up with the Solution Manager automatically for you. So you can have that selected, and every time you make a move it'll come up so you can see what moves are happening. I'll explain some of the colors here for you. Green is the face, the active face. The blue faces are the faces that are moving with change due to live rules or locked dimensions. And the purple face is a procedural feature. If we grab this front face and make a move, I'll show you some more colors. Orange faces are faces that are failing to move. In this case, it's because of the locked dimension. We also have a black face over here. This face has been grounded. So if we want to, we can isolate a face by clicking on it. So if we want to isolate this hole here, we can click on it. It becomes red. That means it's isolated now. If we click on it again, it'll add it back to our select set, and it becomes the dark blue because it severed the relationship with this locked dimension down here. If you make a move here, if we move this, we want to add 50 here. It's going to fail, and when it fails, it'll automatically bring up the Solution Manager for you, and you can make changes to so you can make this edit. So if we relax this relationship or this dimension down here, it'll then allow us to make this move. We can accept it. If we turn our PMI back on, you can see that it's locked this dimension again for us. So we'll open up another part. I'll show you some more examples. We've got some faces here, coplanar faces, and let's say we want to move all the teal faces, but we don't want any of the X'd faces to move. We also have a parallel relationship between these two faces as well, so we'll have to break that relationship so we can move the faces. So what we're going to do is click this top face here, start to make our move, hit Control-E to go to Solution Manager. Now if we right click on the face here, it'll bring up this box here with the different relationships that are on that face. You can see that we have parallel with the X face on the right over there. You can also see we have two dimensions to the face, and we also have the coplanar with the other two faces to the right. Now what we want to do is we want to turn off this relation or this dimension because we don't want that locked. We want to be able to move that face freely up and down. We also want to turn off this coplanar relationship because we don't want those X faces coming along for the ride with us. Now if we right click on this top face, we can again see we have a dimension to this top face, and it's also coplanar and similar to these other faces. So if we want to go in and turn off those other X's, what we can do is just left click on each one of those faces. You'll see they'll turn red, and that means we're isolating them and we don't want them to move with our synchronous move here. So now if we right click and accept this, you can then see that it's only moving those teal faces and not any of the X faces. So that's how you can use Solution Manager to go in and edit what faces you want to move and what relationships you want to suppress. All right, now we'll talk about bounded surfaces a little bit. The bounded surface command has been enhanced to enable creating n-sided patches. The user can now chain select edges of the area to be filled also. Before you had to do single select and select each edge. Now you can do chain and it'll select all the edges for you. You also have these bounded surface options, and I'll talk about them here. You have the no merge option, which always creates a patch if a solution is possible. even if that patch contains multiple faces. The merge is the default setting, which attempts to minimize the number of faces in that patch. And then you have full merge, which only produces a patch in cases where a single face patch is possible. If a single face solution is not possible, then the command fails, and you can just change it then to merge. And if the user only ever wants to use single face patches, then using the full merge can help speed up performance. And then you also have a couple options: planar, surface, and smooth internal edges. And planar attempts to force the creation of a planar surface if possible. And when smooth internal edges is on, internal edges and the generated patch must be smooth, so it'll smooth out these edges for you and make them smooth. Now with the round edit behavior, historically, when a round was edited, the round axis would float. The adjacent faces of the round remain fixed, which is desired when the rounds are truly intended to be treatment type rounds. When the rounds are related to other critical design geometry, though, if the behavior is the same, it can result in more critical design intent being violated. So new options have been added to control how the rounds will attempt to edit. The automatic method will look at the model and try to determine if the radius should be fixed or floating based on the geometric conditions. If there are concentric holes to the blend radius, then it will be fixed. The fixed axis will attempt to ground the axis of the rounds. It keeps the axis from moving when editing the radius value if possible. Float axis allows the center line of the radius to move as the round is changed, which is what the previous behavior was. The axis will move when editing the radius value if possible, and any concentric holes will move with live rules. All right, with threads, the thread feature has been enhanced to enable placing a thread feature with a finite extent to both ends of the cylinder now. And there's also a new dynamic edit control added to specify the depth at placement. When you edit and do like a synchronous move and drag, let's say you start here and start dragging the part to make it longer. After you change the part, it'll then update your thread for you. It won't do it live while you're making the move. Same thing down here. If you make the part shorter, after you make the move, it'll then update your threads and change them back to the thread depth that you had before. So that's some new features with thread there. The sheet metal dimension to bends, you used to only be able to dimension to the theoretical intersection, which would be this point here. You now have the ability to also dimension to the silhouette points on a bend. So now you can either dimension here to the silhouette point, which is where this 81 and this 179 dimensions are. They're on the silhouette point, or you can still use the theoretical intersection that we're used to having. So now you have the option of either one of those. We now have multiple design body options. It now supports ST5 now supports having more than one design body in a single file in both ordered and synchronous part and sheet metal files. There is a new section in Pathfinder dedicated to managing multiple design and construction bodies. Part and sheet metal bodies can also be created in the same file. A new command has been added to the Home tab. The user decides to either create a new part or sheet metal body in the file. You're able to create a new body in an empty file. This enables you to start an empty part file, and then you can add a sheet metal body with no part body defined. And this also then enables you to switch to sheet metal in an empty part file. Once you accept to add a body, any existing bodies in the part become inactive, and new features are only added to the active design body. Also, multi-body files have only one set of physical properties, so all bodies will share the same material settings. And I'll show you all the active and inactive in a minute. You also have some new Boolean commands. and they're designed to work with these multiple design bodies. So you have the ability to do a union, subtract, intersect, or split. So you can do the subtract command. You'd select the target body and then the body that you want to subtract from that target body. Same thing with the union. You select the target body and then what do you want to add to it. You can do an intersect. You select the two bodies that you want to have the intersection of, and then after creating the intersection, those two bodies are then consumed, so you're left with the intersection. And you can also do a split, so you can split a part into two bodies, and then you're able to do the multi-body features on these two bodies, and I'll show you this as well as the subtract in a little bit. When you make multiple bodies, you're then able to publish each of those bodies into their own unique part files. If you have a sheet metal part, after you publish it, you can go in and flatten that sheet metal part. And I'll show you how to publish parts as well. So let's go ahead back into Solid Edge and I'll start showing you some of this. So first thing we're going to do is open up this heatsink and fan assembly. A SolidWorks file, we're just going to open it in a part because we just want a part copy of it. We don't need both individual parts. And what we're going to do is create a bracket to hold these parts together and hang them somewhere if we need to. So what we're going to do is go up here to our add body command. We have the option to add a part body or a sheet metal. We want to add a sheet metal body. We're going to give it a name here. We'll call it hanger bracket and hit OK. And then we can go ahead and start drawing. And we're going to do a coincident plane. We'll pull this off 2 millimeters. And so we're starting to draw our geometry for our new design body. And we're using the existing geometry of the heatsink and fan to create that. So we're going to draw our outline of our sheet metal part here. We'll add some dimensions to that. We can dimension it to our background geometry there. Want it to be 4 millimeters away from the heatsink. Now what we're going to do is a contour flange. Now we have to set our properties for our sheet metal. We could either go to the application button and go to properties and do it there, or we can do it right here on our contour flange command. So we can come here, we want to pick 22 gauge, and we're going to do stainless steel. So we'll select stainless steel and hit apply to model. And that'll apply our material now to our sheet metal part that we're making. So we'll select our chain. We want to pull it over 6 millimeters. So now we have our sheet metal part started. And you can see now in our design bodies over here in Pathfinder, we have the heatsink and then the hanger bracket that we're working on right now. Now if you wanted to, you can go in and we can still do synchronous edits to that heatsink. So if we select this face over here, we can pull that over, and let's say we were given a larger heatsink. We can add length to it here and make that longer if we needed to. We can then come in and make our bracket longer as well. We can add 2 more millimeters to the back side of it. Now we want to do more work on our hanger bracket, so we're going to right click in Pathfinder and make this our active assembly body. And then we want to make our heatsink a construction body as well, so we can do that. And we're still able, though, if we wanted to come in here to our heatsink, click on it, and we can make another synchronous edit to it. So we want to rotate that face back 10 degrees. And we can do that if we want to. So we're going to go ahead and hide the heatsink so we can focus on our hanger bracket here. Next thing we want to do is add a partial flange up here, so we're just going to grab that face, We want our bend outside. We're going to do a partial flange and pull it over. Let's pull it over 3 and down 6. Now the smart dimension, here you're going to see a new thing added. If we place our dimension, we now have the ability here with the arrows in the middle to modify the model symmetrically. Before you could either choose left or right, but now you can choose symmetrically, and that will extrude it in both directions here. So you can see it got bigger on both sides. We're going to lock that because we want to add another dimension over here. That's 2 millimeters to center that partial flange. So now we have it where we want it. We'll come to our radial menu, we'll do a break corner. We can select a face here and just click on these two faces and change that to 1 millimeter and quickly add our break corners there. Our next step is we're going to add a hole. So if we come over to this face here, we can lock it to this face. We come up to our line here. If we hit M on the keyboard, that'll lock it to the midpoint. We can come down and place it then. We can then hold our mouse over the other hole and hit C on the keyboard, and that'll add a dimension between the two center points of our circles. So we want them to be 10 millimeters apart. We then place that then. We'll go back and lock that dimension because we want it to stay 10 millimeters. And we'll add another one just to say how far down that top hole is as well. And we want that driven in the other direction, 10 millimeters. So now here we want to mirror this to the other side, so we can just fence select it, hit our mirror command, choose the plane we want to mirror it across, and now we have it on both sides. Now what we're going to do is we're going to use the split command, and we're going to split this into two parts. But the first thing I want to do is break this mirror because I don't want these two sides affecting each other if we make changes. So we're going to add a coincident plane. We're going to scoot this over 10, and this is where we're going to split the part. So we go over here to our add body commands. We can do a Boolean and we can do a split. We'll click on the part and then click on the plane where we want to split it and hit accept. And now you can see over here in the Pathfinder we have a new design body. We can rename that the filter holder. And to make that the active body that we're working on, we can either right click and say active body or double click on it in Pathfinder. So now we have that as our active body. So we're going to go in and make some changes to it now. Let's move this face down 20 because what we want to do is add a filter underneath the fan, and this is going to hold it for us. So let's make this wider as well. We'll make that 12. Then we can pull this face over. And now what we want to do is add an S-hem to it. So we go into our hem command, click on the face, we'll go into some options, and you have all kinds of different hem types here. We're going to do an S flange, and I have one already saved with a couple measurements in there. So we'll hit OK and apply our hem. Now what we're going to do is add some flanges to add some strength to it. So we'll pull these off. We'll say 10 millimeters. We'll do a quick sketch on it to trim those back a little bit. We'll grab that section there, the region, and we can say through all and go through those two faces and accept that. And we'll do another break corner so there's no sharp corners on this. We'll click these faces and this face as well. Change that to 2 millimeters and hit enter. Now we'll go back to our other part, our hanger bracket. We can double click to make that the active part. We need to make this a little stronger too, so we'll grab these lower faces and pull them up for some flanges. We want to do material inside. We can add a gusset if we want. We'll make that fit in there. I have one saved already. Round gusset here. So we'll hit OK and apply that. Next, what we need to do is we need to connect these two parts because we want them to be rigid in one assembly. So we're going to pull this face through our other part, and we'll have to make a cutout then into our filter holder. So if we go in here and we go to our filter holder and make this the active one, we can do include with an offset because we need to leave a little bit of clearance room in there. We can accept this face. We want to offset it by 0.1 and click to accept that. Then we can grab that region and quickly pull it through to make a nice cutout there for that part. And finally, to lock these two parts together, we have a sheet metal feature here with locking tabs that'll lock these together. So if we zoom in here, we can place this quickly. We want to get this centered up here, so we'll go to the center point of this circle. And then we can click down here, right click, and say attach, and it will attach that locking pins for us. So now we can turn the heat sink back on. And we have a lot of things down here in our Pathfinder, and if you want to see which feature belongs to which part, you can right click up here, let's say on filter holder, and you can say show body name, and it'll show each body name. So you have the filter holder parts and the hanger bracket. You can also right click and go show body features, and that'll highlight them in green, so it's a little easier to see, so you can see which features belong to which part. You can also go up here to, let me save this real quick. We can go up here and go to multi-body publish. And what this allows us to do is if we select both these parts, we can save them out, and we can then edit those parts individually. We can also save out an assembly if we want. We can create this as an assembly, our two parts, and we can open that up. Then you can create a drawing out of that if you want. You can create the flat patterns. So we'll have that create that for us. I'll open up the assembly by double clicking on it. Now here's our assembly we just created of our two sheet metal parts. You can go into them if you want, open them up, go to tools, flat pattern. You can make a flat pattern of this then. So you can save that out, add it to a drawing if you need to. Let me close these real quick. We can open up a drawing I made earlier. So you can still see the heat sink since this construction is kind of a phantom lines there. Here's our assembly with all of our features we created. You can then create other pages with the flat patterns of the sheet metal parts, calling out the different bend sequence and everything. Same with our other part here. And we'll get more into drafting in the part 2 Lunch Byte. I have one more example for you real quick. I know I'm running a little late. So here we have another part. Step file could be from SolidWorks or some program. And it's a part copy over here. Well, we have a new feature in here. We have a lot of holes in this part, as you can see. And if you go to the hole command, you have recognize holes. And what this will do, it'll recognize all the holes in the part, and it'll give you a count of all those holes as well and their diameter and type. You also have the option down here to do face selection. So we can select a face, and it'll only select those holes on that face. You can go in then, and you can also do the whole option for those holes, and we're going to change those from simple holes to threaded. So we hit OK. You can see now it's updated these holes to threaded. After you hit OK, over in Pathfinder, it'll then add those hole features to Pathfinder. If you want, you can also select a face and go back into the hole recognizer. It'll only find holes on those faces. We can then go in and change those as well. Let's say we want to make these counterbore holes. We can apply that setting as well and hit OK. It'll then add those holes to the Pathfinder. And finally, if you run it one more time and just hit OK, it'll add the rest of the holes. So that's the hole recognizer. So if we save this part out, we then use it in an assembly. So let me open this assembly up. If you remember, we had 10 holes that we created and made threaded. And we have a pattern here that if we go in and edit it, you can see that it has 12 recurrences. So we can quickly change that back to 10 so it matches up with our threaded holes. We can also select the hole and change the size because they were 12.5 millimeter holes. So we can make this 13 so that the bolt will fit through, so we can quickly make changes to the assembly like that. Let me change the display configuration real quick. What we're going to do is make some edits to this blade up here. We're going to use the replace part command. So if we select this, we can go up here and we have some options here. We can replace this part with a copy. So if we replace this with a copy, it comes up and we can rename this to whatever we want. You could call it copy. We're just going to call it logo because we're going to add a logo to this part. So we'll save that. It'll open up that assembly then, or we can edit into it, excuse me. Then we want to replace this red piece with another part copy again. We'll accept that. We'll call this part logo as well. And we'll edit that one as well. So if we turn on our background components, we can make a quick change where we want to make this part wider. And since it's a copy, it won't affect the other assemblies that use the same part. So we can make this wider and accept that. Turn our components back off. And what we want to do now is add a logo to this part. So if we go up to part copy, we have a logo here. We can open that and copy it as a construction body. And this is where we're going to use the Boolean subtract. So if we move this down some, let's move it down 185, get it centered. We can go up here to our add body and do subtract. And first we want to select the main body, and then we want to select what we want to subtract from it. So we'll select the logo, and there you can see it subtracted it from it. We go to part painter, you can paint that white so you can see it a little easier. And now you can see where it stands up and what we subtracted from it. So that's how you can use subtract. So we can go back and return back to our assembly here. And there's our logo. Next thing I want to show you is some other features back here. What we're going to do is edit this sheet metal part right here in the assembly. We can pull some flanges off without any other sheet metal commands right now. So let's go to bend outside. We can make this 70. So you're able to do flanges on sheet metal parts within the assembly. We can then edit into that part and make some more changes to it. Let's close these corners up quickly. Let's say we want to weld those, so we want them to be closed so we can make a nice weld bead there. So we'll close those up. Then we can add a dimension here. Again, we'll use the symmetric that we used before. And we want to make this 250. We'll change this width here from 118. We'll make that 130, make it a little longer. Now this dimension, if I click on it, you see we don't have those options. And that's because we have a relationship, a grounded relationship down here. So it won't allow us to pick the other directions because it can only push it up because this face down here is grounded. So we're going to edit that and make that 280. Now under the hole command, we also have a new feature, slot. We can create a slot feature. So if we do that, you have some options here. You can choose the width, what kind of end you want. We're just going to do an arc end. So we'll hit OK. We'll select the line that we want to do it on and place that, and there's our slot feature. So if we close and return here, we can go, and now we can also create a relationship between this bracket and that slot we just created. So if we go assemble, we have a path relationship now. So we can do that. We can go up here, find the center axis of this circle cut out there, and we can relate that to the path of that slot. So now if we do the drag component and we drag this wheel assembly, you can see it'll stop at the end of the slot even if I keep moving my mouse. So now it'll just follow that path and won't go any farther. Next, we can mirror this assembly across to the other side. So let me select these two. We'll hit the mirror command. We want to mirror it across this center plane here. And it comes up with a dialog box here. And what this does is it lets us pick the action for each part that's that we selected in the assembly. So you can either mirror them or rotate them, or you can exclude them if you want. We're just going to leave all these options as they are. And hit OK and finish, and we'll place that other assembly. And I'll drag component here in a second, and you'll see that they're associated. So if I drag one at an angle, the other one will update as well. So we'll do drag component. I'll select this one, drag it to the side, and you'll see the other one will update, and it also turns to the side. Let's say we want to add a new part to the top here. We want a different wheel up here to turn. We can select that. We can go replace part and select the new part that we want to add. Let's add this one to the top. And you'll see it'll automatically add it to the other assembly for us. And we're still able to drag and have that whole assembly come along for the ride. So those are some cool new features. All right, that's all I have for now. Sorry about going over a little bit. It's just a lot of content to go over. I want to thank you for your time. Here's my contact information if you have any questions. Replays of our lunch bites can be seen on our website. I know I went pretty fast with this one. I'll get the replay up today, and you'll be able to watch it and go through the slides again this afternoon sometime. I just want to remind you that on August 16th, it's the What's New in ST5 Part 2. So we'll go over a bunch more new things within Solid Edge ST5. If you have any questions or future topics, please email us those. Once again, I appreciate your time. Thanks, and have a great afternoon.